Hello, today we're going to look at the Mathematics Application and Interpretation Standard Level Paper 2 Specimen Paper. So let's go ahead and get started. In question number 1, it says that in this question we are to give all of our answers to 2 decimal places. So it says that Brian decides to purchase a new car with a price of 14,000 euros, but he cannot afford the full amount. The car dealership is going to offer 2 financing options. So option A, it says a 6-year loan is going to be at a nominal annual interest rate of 14% compounded quarterly. No deposit is required, and repayments are going to be made each quarter. So because we are talking about compound interest, and we're also talking about the fact that we have a loan that we need to pay back, we are going to use the TVM solver. The regular compound interest formula will not be enough for this problem. So when I go to TVM solver, you have to remember that N represents the total amount of payments that are going to be made over the course of the loan. So it says that we are going to have a 6-year loan, and you're going to make a payment each quarter. So if I have a 6-year loan and I'm going to make 4 payments a year, that's 6 times 4, which is 24 total payments. Then the interest rate is 14%. The present value of the car is going to be 14,000. And then the payment that you make, we don't know yet. And then the future value of the car is going to be 0, or the future value of the loan is going to be 0. You're going to make 4 payments per year, and it's going to be compounded 4 times a year. So now that we have our information in there, we're going to highlight payment and press alpha enter, and then we get our answer here. So here we see that our payment is going to be $871.82. So now we want to find the total amount that was paid for the car. Well, if I made 24 payments and each payment was $871.82, I will end up getting that my total payments will end up being $20,923.68. Next, we need to find the interest paid on the loan. So remember, the interest that's paid on the loan is going to be the total amount that you paid minus the original amount that it cost you. So I have to subtract 14,000 from $20,923.68. And when I subtract, I see that my interest paid on the loan was $6,923.68. All right. So now for part B, finance option B, it says a 6-year loan that's going to have a nominal interest rate of R% compounded monthly. Terms of the loan require a 10% deposit and monthly payments of $250. So I'm going to go back to the TVM solver, and then I'm going to type in the following information. So it says a 6-year loan, and you're going to have monthly repayments. So I'm going to have 6 years and 12 payments a year, which gives me 72 total payments. I do not know what the percent is, so I'm just going to skip over that temporarily. And then it says that you have to make a 10% deposit. So if I'm making a 10% deposit, that means that I'm paying 10% of it up front in cash, which means I'm only financing 90% of it. So my present value that my loan is going to be 0.90 times 14,000. And that's going to give me that I'm only taking out a loan for 12,600. All right. So that is how I can figure out how much is going to be borrowed. So the amount that's going to be borrowed is going to be 90% times the 14,000, which is equal to 12,600. So that's how much it's going to be financed here. All right. So now we need to calculate the interest rate. We have to keep in mind that, remember, it says you want to make a monthly payment, so that means you're going to have 12 payments per year, and the interest is also compounded monthly as well, so the CY is going to be 12 as well. So now, if I want to know my interest rate, I'm going to highlight where the I is, and I'm going to press alpha enter, and I will end up seeing that my interest rate will end up being, it says the monthly repayments is 250. So here, if I put negative 250, because that's my payments, and I recalculate my interest rate here, my interest rate is going to end up being 12.6%. That's going to be my interest rate. So C, it says, which option should Brian choose and justify your answer? So the option that he should choose is going to be the option that is going to be cheaper for him in the long run. So we could see that for finance option A, he paid a total interest of $6,923.68. So if I want to figure out how much interest he paid over this amount of time here for option B, I would take 250 and I would multiply it. I would take 250 and I would multiply it by 72 so that we can see how much money that was. So 250 for 72 payments, that's going to be 18,000, okay? And then remember, you have to subtract the 14,000 so that you can get your interest. So the option that you should choose here is it should be option B, because you only pay $4,000 in interest versus $6,923 in interest. So here I'm going to put for part C, I'm going to put option B, because he only pays $4,000 in interest. Okay. So next it says Brian's car depreciates at an annual rate of 25% per year. Find the value of Brian's car 6 years after it is purchased. So I'm going to use the TVM solver as well for this again. So now if it says the value of his car depreciates by 25% each year, that means if I'm saying 6 years and it's going to decrease 25% per year, I know that over those 6 years, it's going to decrease in value 6 times. So my N is equal to 6 here. All right. My interest rate is going to be a negative 25%. My present value of the car is going to be 14,000. When we look at our payment, we're going to put that our payment is 0 here because I'm only talking about the value of the car, how much the car is worth over time. That has nothing to do with the payment that I'm making on the car. And then, your future value will want to be 0. Your payments per year and your compounding periods per year is going to be annually. And then we need to go and find the value of the car 6 years after it was purchased. So what we end up doing here is, if I want to figure out the value of the car, I just want to find my FV for this portion. So I'm going to highlight alpha, enter, and then I will see that the car is going to be worth $2,491.70. Okay. Another way that you could have done this is you could have done it using the regular geometric formula, which means that you could say that you're going to start off with 14,000, or you could say that you're using, instead of the geometric sequence formula, you could say that you're using your compound interest formula. Just know that it's going down. So you could say the value that you began with, so that's 14,000, and that's going to be times 1 minus, and then here we're going to have 25%, and then that's going to be over 100 times once a year, and then we're going to raise it to the power of 1 times 6, and you will end up getting the same exact answer here. All right, so now let's look at number 2. So for number 2, it says Slugworth Candy Company sells a variety pack of colorful shaped sweets. So what we have to do here is they want us to understand that the sweets are produced such that 80% are star shaped, 20% are shaped like a crescent moon. It is known that 10% of the stars and 30% of the crescent moons are colored yellow. Using the information, we want to copy and complete the tree diagram. So, of course, you will have to write this out and copy it and then fill it in. All right. So, if I already know that of the star shaped, if I know that 80% are star shaped and 20% are shaped like a crescent moon, it says 10% of the stars and 30% of the crescent moons are colored yellow. So that means that the crescent moons that are colored yellow is going to be 0.30. The opposite of being yellow is being not yellow. So to be star shaped and be not yellow, then that means that that's going to be approximately 0.90. And then to be crescent moon shaped and not yellow, that's going to be 0.70. So that is how I would finish filling in that tree diagram. So part B, it says a suite is selected at random. Find the probability that the suite is yellow. So there are two ways that the suite could be yellow. So the suite could be yellow by looking at the probability that you have a star shaped and is yellow, or it's going to be a crescent moon shaped and yellow. So remember, every time we say the word and, we multiply. Every time we say the word or, we add. So this is going to be equal to the probability that you're going to have star shaped and yellow. So that's going to be 0.8 times 0.10, or that means to add a crescent moon shape. So that's going to be 0.2 times 0.30 or 0.3. All right. So once we do that, we have 0.8 times 0.10 plus 0.2 times 0.3, and we end up getting 0.14. So that is my answer for B part 1. So B part 2, it says, given that the suite is yellow, find the probability that it is star-shaped. So I'm telling you that I'm giving it to you and I'm telling you that it's yellow. We want to figure out the probability that it's also star-shaped. So if I have the probability that it is star-shaped, given that it is yellow, that is going to be equal to the probability that I'm going to be star-shaped and yellow divided by the probability that I am already yellow. So remember, we already found the probability that you are going to be yellow, which is going to be 0.14. We found that in part B1. And then if we look here, we are going to look at the top, which means that we want to find the intersection, the probability of when it's star-shaped and yellow. So that's going to be 0.8 times 0.1. So once I put that into my calculator, 0.8 times 0.1, and then I divide by 0.14, I end up getting that this is approximately 0.571. So that is going to be the probability there. If you want to put it as 57.1%, that's fine. If you wanted to convert it to a fraction and put 4 over 7, that is also fine. Either or. All right, so next it says, according to the manufacturer's specifications, the colors in each variety pack should be distributed as follows. So we have the color versus the percentage. It says Mr. Slugworth opens a pack of 80 sweets and records the frequency of each color. So to investigate if the sample is consistent with the manufacturer's specifications, Mr. Slugworth conducts a chi-square goodness of fit test. The test is carried out at a 5% significance level. So part C, they want us to write down the null hypothesis for this test. So the null hypothesis is basically going to say that nothing is changing. In other words, it's basically saying that the colors of the sweets are going to be based off of the manufacturer's specifications. All right. So D, they want us to copy and complete the following table in the answer booklet. So they want us to figure out the expected frequencies. So basically, in order to find the expected frequencies, we are going to need to figure out the total amount of the observed. So what we have to do is we have to add 10 plus 20 plus 16 plus 18 plus 12 plus 4. When we add that up, we get 80. All right. So now that we have 80, we have to use the percentages to figure out how many we should actually have. So I should have 15% of brown. So 15% times 80 is going to give me 12. So I know I should have 12 brown, um, 12 brown pieces of candy, or 12 brown sweets. I need 25% of reds. So I do 25% of 80. That's going to give me 20 red sweets. I need 20% green sweets. So that's going to be 0.20 times 80, which is going to give me 16 green sweets. I have 20% orange sweets as well. So that's going to give me 16. And then I need 10% of 80, which is going to give me 8. So I need 8 yellow and 8 purple sweets. All right, so that is how we get our expected frequencies. So now part E, it says we need to write down the number of degrees of freedom. So remember, your degrees of freedom is equal to the number of categories. So we have 6 different colors, so that's 6 categories minus 1. And because our degree of freedom is the number of categories minus 1, we already know that the degree of freedom is going to be equal to 5. So that is part D. So next, for part E, it said, for part, that should be part E here, because part D was where we filled in the table. So the degrees of freedom was part E. So part F says that we want to find the p-value for the test. So if we want to find the p-value for the test, we need to calculate the chi-square statistic. So here we're going to go to stat. We're going to go to edit. Our observed frequencies are going to go in L1, and our expected frequencies are going to go in L2. So once I do that, I then press stat, go over to test, and I'm going to go to chi-square GOF for goodness of fit. So that's going to be D. And I know that my observed list is in L1, my expected list is in L2, and it has already calculated my degree of freedom for me, which is 5. So now I can go down to calculate, and then I see that my p-value is approximately 0.469. All right. So that is my p-value. Now, last but not least, for part G, they want us to state the conclusion of the test, and we need to give our reason for the answer. So we see that our p-value is less than the significance level, or our p-value is greater than, and that's 0.469 is actually greater than 0.05. So anytime our p-value is higher than the significance level, then we are going to fail to reject the null hypothesis. So based off of this, I know I'm going to say that we're going to accept the null hypothesis, and we know that we're going to say that it's insufficient evidence or not enough evidence to reject the manufacturer's specifications. And anytime they talk about evidence, they are referring to the p-value versus the significance level. All right. So now let's look at example number 3. So example number 3 says that the Malvern Aquatic Center hosted a 3-meter springboard diving event. The judges Stan and Minsun are awarded 8 competitors a score of out of 10. Okay, the raw data is collected in the following table. So we have Stan's score is going to be X, Minsun's score is going to be Y, and then we have our different competitors. All right, so part A, it says write down the value of the Pearson's product moment correlation coefficient R. So in order to do that, we need to press stat. We need to go to edit. We're going to clear out whatever is in L1 and L2. We're going to put our X values in L1, making sure that you are very careful with what you're typing in, and put our Y values in L2. Seven 7.2, 7.89, 9.5, and then 7.2. All right, so now that we have those values in L1 and L2, in order to calculate our Pearson's product moment correlation coefficient R, we are then going to press stat. We're going to go over to calc, and we're going to run our regression test for linear regression, which is number 4. And we're going to go down to calculate. And as you can see here, I do not see an R on my screen. It just gives me my equation, and it gives me the value of my slope and my y-intercept. So if your R does not pop up on the screen, that just means that you have not turned on your stat diagnostics. So in order to turn on your stat diagnostics, you need to press mode, go down to stat diagnostics, and then go to on, and then press enter, and then it will be on. So then we can go back and repeat the process. And now we will end up seeing that there will be an R value. And the R value here is going to be 0.909. All right, so that's the Pearson's correlation coefficient. So now it says, using the value of R, interpret the relationship between Stan's score and Minsun's score. So we can already tell here that since we have 0.909, we already know that this is a strong positive relationship. And it's actually a very strong positive relationship because it's close to 1. So now for part B, it says write down the equation of the regression line y on x. So that all that means is that we put our equation in the form of y is equal to ax plus b. And they have already given us our values here. So my equation is going to be y is equal to 1.14x plus 0.578. That is my regression equation there. So now for part C, it says use your regression equation from part B to estimate Minsun's score when Stan awards a perfect 10. So what I do is if I'm saying Stan is going to award a perfect 10, I'm just saying that I substitute in 10 for X. So we're going to have Y is equal to 1.14 times 10 plus 0.578. So I can literally type this in the calculator. And I end up getting that his score is 11.978. That is what his score will be. Of course, if I were to round this to 3 sig fig, I could say that this is approximately 12. All right, so that's what would be the approximate score. for Min's son based on Stan getting a perfect 10. So part 2 is saying state whether this estimate is reliable. So what you have to understand is that when we look at the original table here, we see that this formula or the equation of our line, of our regression line, is based upon the following x values. So if we look at these x values here, the issue that we are going to see with this prediction of having a perfect 10 or of Stan scoring a perfect 10 is that that score of a perfect 10 is on the outside of what the competitors that competed scored. So anytime we have your X value that is outside of the range, that is what we call extrapolation. Okay. So that means that it's not going to be a good indicator because all of my X values that I'm using here or my independent variables are in between. They're from all the way from 3 to 7.5. 10 is on the outside of that. So I know that that score is going to be outside of that range. So that is my reasoning there for part 2. So here I can say 10 is outside the range of X values. So I know that this is not going to be reliable. So this is not reliable, and that is the reason why. All right, so now it says the commissioner for the event would like to find the Spearman's rank correlation coefficient. So in order to find the Spearman's rank correlation coefficient, you have to rank each of the numbers. So we are going to rank these numbers from lowest to highest. So we can already see that based off what they put here, we can already tell that if G is ranked 1, we already know that we're ranking the biggest number to the lowest number. So if 7.5 equates to a ranking of 1, then we should know that the next number that's lower than 7.5 is 7.1, which is point E. We should understand that the ranking of the 7.1 for Stan is going to be 2. Then if we look at the next number below 7.1, that is going to be a 6. And I see that we have 3 of these 6s here. So instead of us saying that 1 6 is 3, 4, and 5, instead of us saying that, we have to be very strategic because we can't really judge which one is going to come first. So the way we normally do that is we normally add them up and then we divide them. Okay. And then we will end up getting our value. So if I take 6 and I do 6 times 3 and then I divide it by 3, we end up getting 6. So because my value is still 6, or excuse me, what we would have to do is we would have to understand that this will be 3, 4, and 5. So I would add up 3 plus 4 plus 5 because I don't know which way they're going to be. If I take that and I divide it by 3, that's going to give me that I have my rankings of 4. So each of these are going to have a ranking of 4 here for the values with 6s. I put the average value in there. Now, once I do that, what I end up having to do is I go to the next lowest number that is below 6, and I end up seeing that the next number below 6 is 4.3. So I already know that that is going to be, instead of it being, it can't be 5 because remember the D, F, and H were technically spots 3, 4, and 5, so I have to go next. The reason why I remember you only found the average of them because you couldn't tell which one came first. So I can't use 3, 4, or 5 in order to rank them, so I have to go to the next number, which is 6 here. And then for A, that's the next one. So that one is going to be 7. And of course, the 3 would be the 8. All right. So then what I want to do is I want to do the same thing for men's sons. So as you can see, based off the rank for men's sons, G is going to be ranked 1, which means that F, which has a value of 9 for men's son score, is going to be ranked 2. And then the next value that's lower than that is going to be 7.8, which is E, which is going to be ranked 3. And then D is 7.2. And just like D is 7.2, H is also 7.2. So what I have to do here is since I know that both of these are 7.2s, I know that I would have both of these will be ranked 4 and 5, but I don't know which order. So if I take 4 plus 5, I get 9 and divided by 2. So that tells me that I should have a 4.5 there for each of those. H is already have 4.5. D is also going to have 4.5 as well. But you have to make sure you understand that if I were to talk about my rankings, they're whole numbers. So I would have 1, 2, 3. One of the 4.5s would be like the 4, and one of the 4.5s would represent the 5. So the next number up from that will be the 6. So my ranking of 6 is going to come from the 4.8, which is C. And then the next number smaller than 4.8 is the 4.7, which is A, which is going to give me 7. And then, of course, 4.6 is lower than that, which is going to give me the ranking that they got, which is 8. So that is how I can complete my table based off of rankings. So now I want to find my Spearman's rank correlation coefficient. So what I do is I go to Stat, Edit, I clear out all of the values in my list, and then I'm going to type in my rankings. Now that I have those values in, I'm going to do the same thing, and I'm going to press Stat, go over to Calc number 4, and then I'm going to calculate my value of R. You would just need to make sure you understand that the value of R here is not the Pearson's moment correlation coefficient. It is your Spearman's rank correlation coefficient, because this R value came from the rankings, okay? So now that I have that, I could easily say that my Spearman's correlation coefficient is going to be 0.933 in 3 significant figures. So then it says that we want to comment on the result that we obtained. Okay, so anytime your Pearson's correlation coefficient is positive or negative, you have to understand that the purpose of Spearman's ranking correlation coefficient is we're trying to figure out whether there is a linear relationship. So because I have a 0.933, I can tell that this is a positive linear relationship, which means that Stan and Minsun, they strongly agree on the ranking of competitors. They feel like as the ranking, as Stan rank increases, Minsun's rank is going to increase. They correlate with each other. So that means that they agree in their rankings. So we can just say that they agree. So Stan and Minsun both agree on their rankings. So that's what that means. All right, now for part F, it says the commissioner believes Minsun's score for competitor G is too high, and so decreases the score from a 9.5 to a 9.1. It says, explain why the value of Spearman's rank correlation coefficient, R sub S, does not change. Okay, so if we were to decrease competitor G from a 9.5 to a 9.1, if you look at the top here, if I go here, I'm going to highlight this value of 9.5 here. And if I were to change this value to a 9.1, it is still the highest number, which means that the rank is not going to change for G. The rank is still going to be the same because 9.1 is still higher than the rest of the numbers. So here we can say that decreasing the score does not change the rank of competitor G. So if the rank isn't changing, then we already know that the Spearman's rank correlation coefficient is not going to change because that correlation coefficient is based upon the rankings. All right. So that was question number 3. So question number 4, it says that the Happy Straw Company manufactures drinking straws. The straws are packaged in small, closed, rectangular boxes, each with a length of 8 centimeters and a width of 4 centimeters and a height of 3 centimeters. The information is shown in the diagram here. They want us to calculate the surface area of the box in centimeters squared. So what you have to understand about the surface area of the box is that you're basically just finding the area of all the surfaces. So front, back, left and right, top and bottom. So if I wanted to find my surface area, I know that I want to find the area of the front, which is also going to be the area of the back. So I'm going to have 2 times 8 times 3. So that's the front and the back. And I'm going to make sure I put this as the area of my surfaces. So my area is equal to this. And then it's going to be plus the area of the sides. So that's going to be left and the right. So I'm going to have 2 of them. So it's going to be 2 times 3 times 4 plus the top and the bottom. So that's going to be 2 times the top, which is 8 times 4, just like the bottom. So once I do that, I can literally type that into the calculator, and I already know that 8 times 3 is 24, times 2 is 48, plus 2 times 3 times 4, that's 24, plus 8 times 4 times 2, so that's 64. So when I add all of that up, I get 136 centimeters squared there. So that is my surface area, 136. Next, it says calculate the length of AG. So from A to G here, that is my line here. And let me make that a little thicker. All right, so from A to G, that is that line there. So in order for me to calculate how long A to G is, I would have to use my Pythagorean theorem here in order to figure out this amount. So what I would need to do here is I'm going to create a right triangle. And I see that that's going from A to C. So if we look at triangle A, B, and C, we already know that that is a 90-degree triangle right there. So in order to find the hypotenuse, or from A to C, or the diagonal going across it, we would basically we would say 8 squared plus 4 squared. So 8 squared plus 4 squared is equal to 80. And of course, we will have to take the square root of 80. And that is going to give us approximately 8.94. So I already know that this portion here is 8.94. All right, that's how long the hypotenuse is across the bottom. All right, so now if I want to find the length between A and G, I already know that I can use the Pythagorean theorem here because this is a 90-degree triangle. Okay, this is a 90-degree triangle that I have made. So because that's a 90-degree triangle, I can use Pythagorean theorem again, which means I am going to end up having 8.94 squared plus 3 squared is equal to, we can say c squared, or the hypotenuse. And we already know that we are going to take the square root of it, so that's going to be the square root of 8.94 squared plus 3 squared. And we will end up getting 9.43 as our the length from A to G. So once we get that, that'll be my answer for B. Okay, and I already know, like I said, from A to G, I can basically say that that is 9.43. All right, so now it says, and I'm going to go ahead and write that 9.43 on the picture in case I need it. So next it says, each week the Happy Straw Company sells X boxes of straws. It is known that the derivative of P with respect to X is equal to negative 2X plus 220, where and it says that X has to be greater than or equal to 0, where P is the weekly profit in dollars from the sale of X thousand boxes. So part C says, find the number of boxes that should be sold each week to maximize the profit. So remember, anytime you have a maximum or a minimum or an inflection point, that is what we call a stationary point, meaning that the gradient is equal to 0. And we already know that dealing with calculus, gradient is the same thing as derivative. So for part C, I already know that my derivative is negative 2x plus 220. And if I set that equal to 0 and solve for x, I will end up getting negative 2x is equal to negative 220, and divide both sides by negative 2. And negative 220 divided by negative 2 is 110. All right, so that means, remember, it says that X is going to represent, it says P is the weekly profit in dollars from the sale of X thousand boxes. Okay, so because it says that we need to figure out how many boxes we should sell each week, then I know that if X is 110 and that's going to represent the number of boxes, then I know I should be saying that we are dealing with 110,000 boxes. So that is my answer for part C. So then it says the profit from the sale of 20,000 boxes is $1,700. So in order for me to figure out the profit from the sale, I need to actually know what P is. So what we have to understand here is that anytime you go from your derivative and you want to get back to your original function, that is the same thing as finding the antiderivative. So I need to find P of X, and P of X is going to be equal to the integral, or the antiderivative, of negative 2X plus 220 with respect to X. So of course, when I find my integral, I'm going to add 1 to my exponent and then divide. So I'm going to have 1 plus 1 here, because that X had an understood 1. So that's going to be I'm going to increase my exponent to a 1, to 2. So instead of that exponent being the x to the power of 1, it's going to be x to the power of 2. And then I'm going to divide by 2 here. And here for the 220, it's going to be x to the power of 1. And of course, when I divide by 1, nothing's going to change. So my P of X is going to end up being equal to negative x squared plus 220x And then we're going to have to put plus C here because we had to take the derivative of a constant. And when we take a derivative of a constant, it's just zero. So the integration of a constant is just what we call C. All right. So now that we have the integral or the antiderivative of our dp dx, or our derivative of p with respect to x, and now that we have our profit equation, we can still see that we are missing our constant of integration here, so we need to find that. Well, remember, it says that here that the profit from the sale of 20,000 boxes is $1,700. We have to just keep in mind that x, it represents the thousands of boxes that are there. All right, so when we substitute that information in, we're going to have 1,700, which is the profit, and that's going to be equal to negative 20 squared plus 220 times 20 plus C. And then we have to simplify the right-hand side. So if I have negative 20 squared plus 220 times 20, we end up getting 4,000 plus C. And now that we have 4,000 plus C, all I have to do is take 1,700 and subtract 4,000. And I will end up getting negative 2,300 is equal to C here. So when we write our actual profit equation, it is going to be written as P of X is equal to negative X squared plus 220X minus 2,300. Okay, so that is going to represent our profit there. So that is my actual equation of P of X. We had to find a specific value for C. So now that I have part D solved, I can then go and solve part E. So part E says, find the least number of boxes which must be sold each week in order to make a profit. So what you have to understand is, when we say make a profit, that means that you have money that is left over. So anytime your profit is zero, that means that you have broken even. That means that your expenses is going to equal what you bring in, or your revenue. So if I want to have if I want to make a profit, then that means that my graph needs to be above the x-axis. And what I mean is this. So if we go to y equals and we type in our profit equation, or our profit function, we're going to have negative x squared plus 220x minus 2,300. And if I graph it, and you may have to zoom in or zoom out to get your graph to look like mine, but when I graph it, this is what I see here. So I'm going to use the trace function so that you can see where my cursor is. So basically, my profit is in the negative when it's below the x-axis, so I lost money. When my graph goes above the x-axis, that is me having a profit. If my graph touches the x-axis, that means that my profit is zero. So I'm trying to figure out the least amount of boxes that should be sold in order to make a profit. So basically what I need to do is I need to figure out how many boxes will it take for me to break even. So if I'm saying what is the least amount of boxes, I'm going to be looking on that left side of the graph. Basically, I'm going to be looking at that left x-intercept. So when I go to second trace, I'm going to go to 0 and I'm going to calculate my x-intercept. So I go to the left side of it and press enter. And then I go to the right side of it and press enter again. And I end up seeing that when I set this equal to 0 for part E, when I set this equation equal to 0, I'm going to end up having negative x squared plus 220x minus 2,300 is equal to 0. So once I set it equal to 0, you have to understand that that is my x-intercept, which indicates that my profit is 0. So once I do that and I put it in the calculator, I ended up seeing that my X value is going to be equal to 11.005. But if I were to put it in thousands, if I were to write my answer in thousands, that means that I will end up having 11,005 boxes, and then I would have a part of a box left over, which means that if I want to make a profit, then that means that I need to round it up to the nearest whole number, which means that I need to sell 11,006 boxes in order to make a profit. All right. And I know that that is true because if I go in and I substitute that value of X in, I will end up getting a profit. So if I wanted to check it, I could say negative, and then in parentheses, I would have 11.006 squared. Remember, when we put it into the function, we don't actually put it in thousands. We have to write it. Remember, X is already in thousands. And then I will have plus 220 times 11.006, and then minus 2,300. As you can see here, that is a positive number. It's just really small. And I see that I still made a profit. It may not have been much, but I made a profit. If you were to say that it was 11,005 boxes, you would have plugged in 11.005. And as you can see here, my profit is negative, which means that I lost money. My goal is not to lose. My goal is to gain. All right. So that is how we do part E. So if we look at number 5 now. So for number 5, the question says the braking distance of a vehicle is defined as the distance traveled from where the brakes are applied to the point where the vehicle comes to a complete stop. The speed S, which is in meters per second, and the braking distance D meters of a truck are going to be recorded. This information is summarized in the following table. So we have this information in the table here, and then it says below that this information was used to create model A, where D is a function of S and X has to be greater than or equal to 0. So if we look at model A, it says that we should have the equation D of S is equal to PS squared plus Q times S, where P and Q are integers. Remember, this means integers, positive or negative whole numbers. So it tells us, it gives us a clue here that at the speed of 6 meters per second, model A can be represented by the equation 6P plus Q is equal to 2. So part A, it says write down a second equation to represent model A when the speed is 10 meters per second. So I want to write a second equation for part A. So if I write that second equation for part A here, I'm going to, it says where we have the speed as 10 meters per second. So I'm looking here on the table. So I'm going to substitute that value in. So it says my braking distance is 60. So I am going to end up having 60 is equal to, and then I'm going to have P times 10 squared plus Q times 10. All right, so that is my equation there. So once I do that, I am going to simplify. So that's going to be 60 is equal to 100P plus 10Q. And I know that everything can be divided by 10. So if I simplify this, if I divide everything by 10, I will end up getting 6 is equal to 10P plus Q, because everything can be divided by 10. So now that I have that, I can go to part 2 and I can find the values of P and Q by using the Poly Simo 2. So when I press apps, I'm going to go to the Poly Simo 2 app, And then remember, you go to simultaneous equation solver. We're going to have two equations. Remember, the first equation they gave us up here at the top. So 6p plus q is equal to 2. And then we have the one at the bottom. So I have two equations, two unknowns, and then I'm going to go to graph to go to next, and I'm going to type in my coefficients. So here I'm going to have 6, 1, and then a 2. And then on the bottom one, I'm going to have a 10, a 1, and then a 6. Your calculator may look different than mine, where it's easier for you to type your equation in because it will actually look like the equations on our paper, except it will have x's and y's. But if your calculator looks like mine, you will have to put it like this in the matrix using the coefficients. Once you do that, then you are going to press graph, and then it is going to solve it for you. So for part 2 from the PolySimo 2 app, we end up seeing that P is equal to 1 and Q is equal to -4. Anytime if your calculator looks like mine, if you have x of 1 and x of 2, that is basically saying what is the value of x in the first column going up and down, and then the value of the variable in the second column going up and down. So that's how we know that 1 belongs with P, and we know that Q belongs with 4. So, or -4. So what we are going to do here is now part B, it says we want to find the coordinates of the vertex. Well, if I want to find the coordinates of the vertex, all I have to do is just substitute these values for P and Q back into the function. So for part B, my equation that I'm going to be looking at is going to be D of S is equal to P, which is 1. So that's just going to be S squared. And then we have plus -4, which is just -4s here. That is going to be my equation. So if I want to find my vertex, then all I have to do is exit out of this app, go to y equals, clear whatever was in there out, and I'm going to put in x squared minus 4s, or x here. And then once I do that, I'm going to graph it. And I see that my vertex is a minimum. And if you want to, you can zoom in 6 for standard so that you will be able to see things clearly. So there is a clear graph there. So if I want to find my vertex, I know that that is a minimum. So I'm going to go to the left side and press enter, and then go to the right side of it and press enter again. So as you can see here, my minimum is approximately a 2.0000008, and then -4. So always go to the table to verify. So I'm going to look at where my y value is -4 and that x value is a 2. So here my vertex, or my minimum, is going to be located at 2, -4. So that is my answer for part B. So for part C, it says, using the values in the table in your answer to part B, we need to sketch the graph of y is equal to D of S, and we're going to look at the values for 0 to 10 for the S values, and -10 to 60. And then we're going to clearly show the vertex. So what I would do if I were you all is, of course, it will be easy for you to draw this on a piece of graph paper. So I am going to insert me some graph paper here. So once you graph it on graph paper, you need to, of course, you need to create your axis and you need to scale it. So remember, it said that we are focusing on the S values from 0 to 10. So I'm only going from 0 to 10 here, and it says that I am only going from negative 10 to 60 for D. So if I go to negative 10 here on my x-axis here, I'm going from negative 10 to 60. So my graph should be within this range of x values and y values. So I can easily do that by looking at my table. So I already know that one of the points is 0, 0. So I am going to plot 0, 0 on my graph. So that value is here. And then we are going to plot 5, 5. So 5, 5 will be halfway here. I can also plot 4, 0 because that's on the x-axis. I already see that we have 9 and then 45. So 9 and 45 is going to be here. And then I see that I also have 10 and 60, which is going to be here. So now what I have to make sure that I do is I have to be very careful between 0 and 4 on the s-axis or the x-axis here. And I'm going to try my best to approximate 1, negative 3. So 1, negative 3 will be somewhere in here. And then we're going to have 2, negative 4. And that's going to be a little bit above half. So that's going to be somewhere like right here. And then I have 3, negative 3, which it look like is coming back up here. And then once I do that, I can just connect my points with a smooth curve. I even like the point 721 because that's just going to be a little bit above 20 here. So remember, you can always estimate. They're not expecting you to be perfect. So of course, when I graph this function, I'm going to draw my curve through these points as neatly as possible there. So that is my graph here. All right, so that's how my graph is going to look for that specific domain and that specific range. All right, so please make sure you take into account of the values that they're telling you, because they told us here that we're going from 0 to 10 and we're going from negative 10 to 60. All right, and it says that you want to clearly show the vertex. So as we can see here, our vertex is here. So we clearly see the vertex. So as long as you can see the vertex in your sketch, you get full credit. All right, so that was part C. So now back to part D, it says, hence, identify why model A may not be appropriate at lower speeds. Okay, so we can basically say that if we look at the graph here, we already know that anytime that we have a graph or the part of our graph is below the x-axis, that is indicating that there is a negative value there. And if our y values are negative, or if I'm below the if I'm below the x-axis, that means that my distance is going to be negative. Okay, and we already know that we can't have a negative distance. So this is why this will be inappropriate at lower speeds. Okay, because it being below the x-axis will indicate a negative distance, and distance cannot be negative. All right, so that is going to be what we have for D here. So here we're going to say that the graph shows negative stopping distances for low speeds. And we already, like I said, we already know we cannot have negative distance. All right, so that's why that would not be accurate or precise. So part E, it says use model B, and they have already told us that additional data was used to create model B, a revised model for the braking distance of a truck, and they gave us the equation for it here. So it says use model B to calculate an estimate for the braking distance at a speed of 20 meters per second. So basically, I'm just going to use that equation, and I am going to substitute. I'm going to substitute in 20. So for E, I'm going to have D of 20 is equal to 0.95 times 20 squared minus 3.92 times 20 here. So literally, I'm going to go back to my main screen and I'm going to substitute this into the calculator. So I'm going to have 0.95 times 20 squared minus 3.92 times 20. And I end up getting that my actual distance was, or that the estimated distance was 301.6 meters. All right. So now if we look at part F wants us to know that the actual braking distance was for 20 meters per second for the speed is going to be 320 meters. So we want to calculate the percentage error. So we should know based off what we found that the value of my exact is going to be 320 and that the value of the approximate braking distance is going to be 301.6. So if we use our percent error formula, we know that this will be equal to the absolute value of your approximate, which is going to be 301.6, minus the exact, which is 320, divided by the exact, which is 320, and then we're going to multiply that by 100. So I'm going to press math, go over the number, absolute value, then type in my fraction, alpha y equals. That's going to be 301.6 minus 320 divided by 320 times 100. And I will end up getting that my percent error is going to be equal to 5.75%. That is my percentage error here. All right. And I'm going to highlight my answer for E as well. And I'm going to highlight my answer for part A, section I, as well as part A, section I, or section 2. All right. So on the next part, it says, it is found that once a driver realizes the need to stop their vehicle, 1.6 seconds will have elapsed. Basically, 1.6 seconds will have went by, okay? That's like your reaction time. It says on average before the brakes are engaged. So it's not every time. Some people may react faster or slower, but on average, 1.6 seconds will be the time that it takes for a driver to realize that they need to stop. So during the reaction time, the vehicle will continue to travel at its original speed. It says a truck approaches an intersection with a speed S in meters per second. It says the driver notices the intersection's traffic lights are red and they must stop the vehicle within a distance of 330 meters. So part G says using model B and taking reaction time into account, calculate the maximum possible speed of the truck if it is to stop before the intersection. All right. So remember, we have the equation for model B here. Model B was given by the equation D of S is equal to 0.95 S squared minus 3.92 S. Okay, so that was model B. So I'm just going to write that down here. So I have 0.95 S, and that is going to be squared minus 3.92 S. All right, so because that is model B, remember we need to take into account the reaction time. So basically, I know that this truck needs to stop within a distance of 330 meters. So in order for me to figure out what my speed should be is, what I'm going to do is I'm going to say, okay, well, if it takes on average 1.6 seconds, I can say, okay, well, 1.6, which is my time, multiplied by my speed, plus the actual braking time, which is going to be given by 0.95 S squared minus 3.92 S. I need that to equal a total of 330 meters. Okay, so remember, the 1.6 S represents how long you traveled by the time you realize that you need to stop. Then the 0.95 S squared minus 3.92 S, remember that model B is talking about the braking distance, the actual braking distance from when you actually start applying the brakes on the truck. I need those two distances to end up being a total of 330 meters. Okay, so what I'm going to do here is I need to solve this equation. So I'm going to enter the right side in L2 and the left side in L1. So I'm going to have 1.6x plus 0.95 x squared minus 3.92 times x, and I want it to be equal to 330. And then I'm going to press graph. So as you see here, I only see one part of my graph, but I should automatically realize that because I have that this is equal to y is equal to 330, I already know that I can just change my window setting and I can just put that my y maximum, I'm going to put it at 350 here so that I can actually see both pieces. So now that I see both graphs, I need to then zoom out so that I can see where they intersect. So we already should realize that the left intersection is going to give me a negative value for S, because remember the x-axis is representing the speed, which is S, and the y-axis is representing the distance, which is D. So if I know that my intersection on the left is going to produce a negative x value, I know that my speed can't be negative. However, I need to find the intersection on the right. So I'm going to go calculate my intersection, get as close as possible, and then press enter 3 times in order to find out what that value should be. And I see that the speed that I need is going to be S, it should be approximately 19.9 meters per second here. So 19.9 is my answer here. All right. So that is how we solve paper 2 for the specimen. If you have any questions, please reach out to me and I will be more than happy to assist you. Have a great day.